Okay, me. Let's do the thing. This is going to be a short stream. I don't know who I'm talking to. There's no viewers. Oh, there are. Hi, Sly. This is going to be a short stream because I have to play Dungeons and Dragons tonight, so let's just jump right in and try to get as much done as we can before I inevitably shuffle off to Master Dungeons. Where was I? Oh, yeah, we were going to do the rotate 46, which is a read, modify, write instruction, and so we needed to modify that. So, I don't know, left shift, same difference. So, shift left currently. Oh, hey, Silver Blaze, I thought you weren't going to come by today. Okay, so currently what we're doing is we're getting the CPU regs, and updating it, and then updating the flags based on that. Do we update the flags based on... Yes, it looks like we do, actually. Okay. I managed to have some time because it's 10 p.m. Oh, okay. Where does that put you? That's not East Coast. It's an hour east of East Coast. I don't know what that would be. Iceland? Anyway. Nova Scotia, Canada. I was kind of close. How are things in the Great White North? I think you guys have some sort of interesting stuff going on at the moment. Sorry. Okay, so write the value back and do the operation, which basically means that we're going to put it in the shul, but we're also going to write it to memory. Or we're going to put it in the IDL, and we're going to write it to memory. Rough at the moment. Yeah, that's what I hear. Okay, I had a great idea for how to handle this earlier, because it kind of goes right into what I was thinking of previously. I'm not sure what to call it, though. Just call it both. Okay, maybe this won't work. Never mind. I'll just do it the easy way. So for shift left and for LSR, ACC or ZPG. ZPG is what we're doing now. ZPG. There's one thing I've been trying to figure out, and I can't seem to figure it out anything through Google. Okay? Okay, so we fetch the opcode, which we already do. Looking at some of the other 0 pages. Where's the ZPG? Dang it. There we go. We're going to fetch here. Did someone mention pizza yet? No. Hello, Spy Crab. Is the NES capable of screen transition effects, like a screen swipe to black and then swipe into the next area? That seems like something that would be possible to me. I haven't done graphics yet. Sai? Does that sound doable? I mean, it does the, like, thing in Super Mario Bros. 3 where it spirals in towards the center of the screen. Flexible scrolling. That sounds like a yes. Okay, so the next thing that we're going to do is read from the effective address. This is read to input data latch. Then we're going to write the value back to the effective address and do the operation on it. Does that mean that the flags get set in cycle 4? And then you write the new value to the effective address. So we do the read to IDL, we do the write. Does read set flags? Because it probably should only set flags. Yeah, it probably should not set flags if it's not being loaded into the real ones. So if regnom, it wouldn't matter when you set flags. Are you sure? Okay. But it certainly should not fetch flags, or it certainly should not set flags if it's reading into a non-flaggy register like IDL or ADL. So match regnom. Any tests working yet? Can it play Metroid yet? No. Whatever. This is bad, but I'll fix it later. Set the flag after the operation has occurred, otherwise things break. But you just said it didn't matter when I set it. Do you just mean I should make flags work? Because, yeah. Okay, so we're going to write back, and then we're going to shift right. Is this the new Beast Nest? Yes, definitely. Any tests working yet? So we're about halfway through Nest tests currently. I'm currently implementing a do a thing in memory. Man. This is such a pain in the butt. It feels like this should just work differently. Maybe I'll just give it an address, and then if I give it an invalid address... No, I can't do that. That doesn't work. What's your favorite NES game? Mine is probably Super Mario Bros. 3. Although, honestly, Super Mario Bros. 2 doesn't get enough love. Alright, I'm going to do what I usually do when I'm kind of stumped, is I'm just going to do this, where I just do the thing, right? And then I'll figure out later why it's bad. Which I'm sure that it is. CPU.RAM, CPU.get address bus. So we read it, we write it back, and then we shift it, and we wait, we already read it, actually. So the old val is, oops, CPU.idl, and then all we need to do is change where we write to be CPU.RAM, CPU.get address bus. Right? That should work. And then we update the flags, and hopefully this is good. Go! No! Because I didn't implement a bunch of stuff. In memory. Gotta as you size it. Go baby, go baby, go baby, go baby. Invalid instruction 6, is that correct? So this is D441. Which is a real thing. And here's the LSR. So that seems to be right enough, anyway. And the invalid instruction is at D443, which is 06, which is ASL. Presumably, it's going to be ASL, yeah, 0 page. So, okay, same exact thing, just change it a little bit. Shift left. Shift left. Change this name. Implement here. And that ought to do it. I was thinking of making a Flash emulator, but then someone started one in Rust. So, do it anyway. Six. Then again, I don't announce multi-system emulators. Well, that's probably a good idea, by and large. Yeah, make your dreams a reality. Don't let your dreams be dreams. Be like Shia LaBeouf, an actual cannibal. Rotate right, chalking. 66. Roar in mem. I have sure in mem. Copy. Actual Madman Shia LaBeouf. Yes, but that's not as funny as actual cannibal because actual Madman is like an accurate description. Did I need to change how this works? I don't think so. I think that's good. Yep. Okay. Boop. Scream at someone who refuses to serve you French fries. What did I do? Invalid instruction 66. It's not. It's right there. Hang on. What dumb thing did I do? Oh, I didn't actually do the thing. Cool. Where is rotate? This is rotate right. There we go. Okay, we're gonna grab left shift CPG, drop it right here, rotate right, and then we'll just change the sure to a roar and we'll be good. Ah! Wow, okay. I can type. There we go. How's everybody doing today? Having a good time? Getting everything done in your lives that you want to get done? This is going to be left rotate. Yep. Do. Left rotate. Headache like a beast. Oof, sorry to hear that. I had that earlier today, actually. Pretty bad sinus headache. Okay, we'll just do this. Business. And then this. Okay. Getting stuff done now despite it. That's good. Oh yeah, I need to actually define the thing. I love technology. 26, I think, is what I'm looking at here. 6. Yep. Go! I got mad Twitter cred now, so yeah. Yeah, absolutely, you were retweeted by Yahtzee. Surely the most famous of all people in the world. Ooh, increment memory. Adds 1 to the value specified or held at a specified memory location, setting the 0 negative flags as appropriate. This is a whole new instruction. This, oh, this is 0 page index. 0 page addressing, inc. So this describes a 5-byte instruction, but this says that it's, oh no, it does say 5 cycles. Okay. Basically the same. I have not yet watched your speedrun, Sai. I'm sorry, I've been busy. I have an increment just do in mem. in mem. Oops, didn't mean to delete you. What speedrun? The speedrun is what he got tweeted by Yahtzee. It seems to be of some sort of meme game. How dare you do something useful with your time? Yeah. Sorry. Sorry, not sorry. Oh, spy. Yes, spy. Ink in map. Okay, so here's increment 0 page. Spy and psi gonna get confusing. Psi is my alt anyway. That does explain a lot. The mooch is my alt thing only works if you are around people who know what the fuck you're talking about. Where is that instruction that I literally just wrote 2 seconds ago? Wow, I've written a lot of code for this at this point. Alright, ink CPG. Excuse me. Okay, so what we're gonna do is we're gonna fetch the address. We're gonna read from the address. We're gonna write to the address, and then we're gonna do ink in mem. I am confused. What is this mooch thing? Yeah, don't look into it. It's dumb. It's a person who used to be present in the community and is not anymore for pretty good reasons. And by pretty good, I mean very good. Spooky. Okay, we don't actually want to update this. We just want to get the value, and then we want to set CPU.RAM, get address bus as usize equals value, and then we'll calculate the flags based on that. Yeah, that should do it. Can't you make your stream more Halloween things? For sure. Someday. Honestly, I've been kind of what is your problem? I've been running pretty... Oh, okay. It's because I got over-ambitious. I've been running pretty flat out on this lately and not really having a lot of time to, like, do extra stuff like spookify it. Maybe after I'm done with this challenge and probably take a few days off, I will do that. Only difference here is this is sub instead of add. I think the text being orange and the background being a dark gray works. It's very Halloween-y. Thank you. That's how I always run my stuff, but I'm glad that it works for the season. Halloween is the best season. For sure. Okay. So, deck ZPG is just a C, and then this, except we call decrement. Oh, I have too much stuff left here also. Let's just get rid of that. And then deck in mem. And also get rid of these. There's not a single skeleton. Unconvincing. Is there a cow say that for skeletons? There should be. Ooh, absolutes. Does that mean we're done with the indirects? Where are we at here? D5-4A. Yep, so we RTS and JSR, which means we're probably in the next set of tests. Awesome. That's really good. So, we've got load y absolute. Let me just grab myself a little bit more room here. That'll be y. It is y, right? Yeah, okay. Load y abs. It's going to be pretty easy to implement. It's AC, it's the address. There's load y immediate. Programmers are just skeletons wearing a layer of skin. That's true. I cannot deny what you are saying. Literally anything underscore abs. LDX abs is a good one. And we'll just literally do exactly that, except we'll change the y to an x, or the x to a y. Oops. Y. Abs. Go. BRB. Okay. HC is STY abs. Do I have any abs? Do I have any store abs in here? Probably not. Oh, no, I do. I have store A. Okay. Store A and store X. All right. So STY is APG. And then also we will go to, oh, we should put this in here, STY ABS, which is, what is it? It's 8C. Yep, C. And then we're going to go ahead and look at STX abs right here, which again is very easy. Just do that. Change it to abs. Call it good. That excuse is pretty bare bones. Oof. Sorry, bone bag. I don't have any radishes left. STY 0 page. Okay. That's interesting. I must have some store 0 page, right? Oh, I do have STY 0 page. What? Did I just not implement that? That's interesting. Alright, what STYs do I have? Abs is the only one that's implemented. Okay, cool. Well, that's sort of weird. I feel like I implemented it before and maybe I just deleted it by mistake. Whatever. Have you all seen the clickhole video about the first time you run out of radishes? It may be the greatest video the internet has yet produced. Or possibly the video which is most to my taste anyway. 2C, here's bit DPG. Change you to bit abs. All you really have to do for abs is fetch twice. Does test go to the... Yeah, it does. Okay. How can that be the greatest when this stream exists? That's true, I did upload 7 videos to YouTube, so those exist now. Okay, or A, absolute. You were right, Sai, that this is pretty easy because of having micro instructions. Should be able to just do this. Why dab on Ziff on stream when we can dab on Ziff when he does the Pokemon stream? Ziff is never going to do the Pokemon stream. It's just not a thing that's going to happen in the world. 2D is and. Okay. We need to clip that. Yeah, do it. I need more clips, apparently. A Weigel dabbing hard on zip. Look, it's not a dab. It's just a prediction of reality that I believe is accurate. The biggest dabs are the accurate ones. I guess that's true. Oops. It won't be long. Uh-oh. Assertion failed. Address less than 2,000. Oh. There we go. That's better. 60 is going to be add carry. Because instructions make sense, kind of. Lofty and I were talking about like the archaeology of looking at instruction sets. If you look at them backwards through time, it's like they don't make any sense. But then if you look at them forwards through time, sometimes they make more sense, and you can see where things get like slid in to gaps because they realize a need. Clipped it, processing right now. Sweet. CD is going to be compare. Yep. And there's comp CPG right there. Do-do-do-do. Absolute. Add an extra fetch. What? Oh, because I've defined it twice. Because I didn't change this. There we go. Posted on server. Good. Erectile dysfunction. Boy, if you don't know what I'm talking about, that was sure a weird thing to say suddenly out of nowhere. Oops, there we go. Uh-oh. What's EC? Is comp X absolute? Didn't I just do that? Oh. I just made it a D, I guess? Wait, then what's ED? Oh, ED is subtractive carry. You have foiled me. Okay. So that's all still fine. SBC 0 page, we can just copy and paste. Back on a roll. $630, sweet. Can't find SBC abs because I didn't change it. I really hope that this stream continues to go this smoothly because I really don't have a lot of time today and I want to get as much done as possible. Abs C. Just copy this. Paste it down. Abs H. All have left are different addressing modes. Yeah, pretty much. And I mean, they're going very simply because I already did them once, and I have whatchamacallums, micro operations. So it's not too bad, except for some of the weird ones like LSR. And even that one should be fine. Just have to fetch twice. Does this change the number of cycles? Yes, it does. Good. Micro-ops to the point where I usually can't be arsed anymore. Yeah, I mean, I get that, but I knew ahead of time. Uh-oh. I didn't change the number. I knew ahead of time that there were going to be some things that cared about sub-instruction accuracy, and I didn't feel like writing a whole thing based around hacking that and then rewriting it. So I decided to start from the beginning. Also, this is weirder, and I like weird stuff, and also this is more in line with what I wanted to do for my N64 emulator. Is that an E? 0E? Yep. How are you going to even solve that with a JIT? You mean for the N64? Yeah, I'm confused also. If you need micro-ops for timing or whatever. You mean if you need both micro-ops and a JIT, which presumably you would for the N64. So, two things there. One, I'm not actually convinced that you need a JIT for the N64. And two, you absolutely can do sub-instruction checks with a JIT. You just have to emit them into the JIT code. It obviously is going to be slower than if you didn't have them, but yeah, I mean, it's more accurate. It's going to be slower. Cry me a river. 2E. Rotate left. Based on my experience with the PS2, I think you do need a JIT. I mean, the, whatchamacallit, that one that guy was doing, Vel wants me to actually dab on stream. Tell Vel that he can donate to my PayPal. What am I trying to say? Sen64. Sen64 doesn't have a JIT. It runs okay, but obviously not great unless you're on a super powerful computer. But I've looked at the code, and I don't think it's like implemented super optimally either, which is, I don't know, maybe a little harsh, but it's how I feel, man. So, isn't full speed even on SM64. It actually is on my desktop. But there's a lot of stuff in there that's like not very optimal, right? Like it basically just uses Angry Lion, as far as I can tell, for the RDP. And it's very like context switchy, and I don't know. I think you could do it a lot better, and without going to a full JIT. That being said, it still is likely, especially if you want to run on like a relatively low-end computer, that you would want to do a JIT, and I have some ideas for how to make that not a horrible performance killer when you go with sub-instruction accuracy. But I don't want to talk about them too much because they're 100% unproven, because as Sai will happily tell you, I haven't actually done anything on that except write a super optimizer to decode instructions. Welcome back, Silver. How much? Good question. I don't know. 20 bucks. Ooh, indirect. That is an expensive dab, but that's what my pride is worth. $20. Okay, new addressing mode. Let's learn. It's a quality dab. Everything I do is quality, Si. Alright, indirect index addressing is the most common indirection mode used on the 6502. In instruction contains the 0-page location of the least significant byte of 16-bit address. The Y register is dynamically added to this value to generate the actual target address. So basically, no, the 2-week challenge does not include audio specifically. I will try and get audio working, depending on how things work. Are you going to set up text-to-speech so I can pay money to have a synthesized voice say the N-word on stream? Absolutely not. Okay, so if I understand this right, you fetch 16 bits from address 40 in the 0 page, then you add Y, and that's the actual target address. Okay. That makes sense to me. Let's just confirm it here. 0 page index, absolute index, is that what we're looking at here? No. We're looking at indirect index or index indirect. Indirect index, okay. I can dab on him myself for free, thanks. Yep, absolutely. Quality but no quantity, am I right? Yeah, I mean, pretty much. That's a pretty fair description of my programming career. Just clip say the N-word on stream. Don't y'all have, like, productive things to do with your lives? Alright, load A. Load A, indirect Y is B1. I should be sleeping, so no. Sleeping is productive. Alright. Twitch isn't for productive things. I agree with that. Certainly not on the watchy side. And even not usually on the righty side, the streamy side. Okay, so step 1, fetch opcode increment PC. Step 2, fetch pointer address increment PC. Right, so we do that. Then we fetch effective address low, effective address high. Oh, this is going to be interesting. Add Y to the low byte. How did I handle this before? Okay, I just baked it into the thing. I do spend a lot of time on Twitch teaching streamers. Oh yeah? At least here you can spam Hong Kong stuff without getting banned, I guess. That's true, because nobody important is watching. Also stand with Hong Kong, obviously. And trans rights, in case anybody wants that one. Okay, so the issue here is that normally this is what I would want to do, right? Fetch to the address buffer, fetch the address buffer, fetch the address buffer. But the problem is that I can't actually do that because I will overwrite the address buffer here and it will do bad things. So I need to fetch somewhere else, and then I need to do something else, because this is fetch effective address high, add Y to the low byte, and then read from effective address. So I'm just going to lump all this into like a microphone fetch indirect. And we're going to fetch this to the IDL. And then it's not going to decode in the instruction. Does Donkey Kong say trans rights, though? I'd be a pretty dread streamer but if it would probably be audio programming stuff. That's cool. Are you a DSP person? Alright, so this is branch set, this is branch clear. This is fetch 2. We want basically qualities of all of these things. So we're going to do fetch indirect. Do I need an argument? No, I'm a web developer. I have heard that audio stuff in the browser is a real pain in the butt. Alien vs. Predator was a pretty good early FPS game. Okay, this doesn't quite match where I want to be. The model doesn't entirely match my current implementation. So I can do the fetch indirect, and then we're going to read from the effective address, and then we're going to read from it again. And that's good enough for a read that doesn't have any operations in it, but for everything else, it's going to be tricky. The easy way to do it would be to have a micro op for each of these operations, but I already have too many micro ops, honestly. That's not the end of the world, especially since all I need to do is get Super Mario Bros. 3 running. And I can always come back and clean some stuff up later. So maybe I'll just do that, but what are we looking at here? Indirect Y. Fetch byte, read 60-bit address from Z page byte, you fetch, add Y to address. Yeah, I got that. But the problem is there needs to be like a conditional no op, which we talked about how like I've done that before. I also need, I mean, I guess actually, you know what? Yeah, let's just do it this way. So there's the fetch indirect, and then we actually do the operation, which in load A is read to, I guess. All right, so this is 5 cycles, and then we'll just, in the check fetch indirect, we'll just add 1. We can do that. The browser is actually kind of nice for audio IMO. It has MIDI, WAS, and JavaScript workers. That's good. I thought I had heard that all the like web audio APIs were very difficult to work with, but I'm glad to hear that that's not true. So instead of get number by reg num, we're going to do regs abh. It's not a reg, it's just a thing that exists. And then we're going to do cpu.abl equals cpu.idl. So we'll move that over. And then this will go away. We're going to do the add, right? So we fetch them both, and then we add y to the low byte is what's supposed to happen here. And then you're supposed to fix the high byte on the next cycle. But I'm not going to do that. I'm just going to insert a no op. So we're going to do let temp adder equal cpu.abl as u16. Oops. Plus cpu.regs.y as u16. If temp adder is greater than ff as u16, then we're going to do cpu.q.push front, probably. Yeah, front. Micro fun no op. 0 or page crossing cycle. And then we're going to do cpu.abh is equal to cpu.abh plus 1. And then obviously there's a problem there because if this hits the upper end of memory, it will explode. But How'd that go? Does that look good? No, it doesn't, because I didn't change this thing. LDA indirect line. Go. Invalid instruction 11. That seems to think that it's correct. So where was that? What is this opcode? This is worth some time to like make sure that it's actually right. So that was opcode B1, which ought to be around someplace. I don't know. I'll just look it up in this listing instead. Oops, too far. B1. D922. Okay. Go way, way up. D922. Okay, so, darn it. Okay, keep scrolling up again. Get back to D922. Alright, D922. So at the start of this, A is 0, which is correct. X is 65, which is correct. Y is 0, which is correct. Stack is FB, which is correct. The processor status is 27, which is not correct, but I know why. It's because I'm updating the processor flags way too often. I have to go through and fix that at some point. And then afterward, the next instruction to fetch is supposed to be an F0, but we just jump over it? Is that right? Something bad is happening here. Okay, so B1 is at D922. Then we're supposed to fetch the thing at D923, but it says that we fetched 0, which is not right. I'm getting so many viewers. Yeah, yesterday we got up to 26. That was the most I've ever had. Something is definitely wrong here. Fetch 2. Oh, well, okay, so that's just not useful at all then. Alright, so we fetched it. And then the next thing is... Oh, okay, so fetch 2 is probably not actually what I want to do here. I think what I want to do is read 2. Or read an increment? What does read 2 do? Read 2 reads it, doesn't increment anything. Reading from address, fetch byte from. Okay, so yeah, we want to do read and increment. And we want to write to IDL, and we want to read from ABL. Alright? Is that going to work? So we'll fetch from the address bus, and then we will write to the IDL that number, and the fetch should increment, I think. Fetch byte from. I have a feeling most Rust programmers would be horrified by those consts. Why? It's a huge bucket of constants. I don't understand why that would be a problem. I mean, I guess I could use an enum, but like, what's the point? Okay, yeah, so we do increment them, so that's exactly what we want. Alright, let's try that again. Holy cow, this is a lot of stuff. Is that wine or Coke? This is wine. I like the subtle dad who's drinking red wine and coating his emu at the same time. Unlike someone else who tried to drink wine while coating an emu. Yes. Video keeps buffering for me. Is it just me? Okay, glad to hear it's just you. Sorry, Silver, though. Those are the instruction codes, right? Yeah, I was thinking of an enum. What kind of wine? It's a Cab Sauv from Chateau Ste. Michelle Winery, which is local here in Washington. Just switch to JavaScript. JavaScript developers will accept you. JavaScript developers accept everybody, which is good, but also bad. Okay. So what happened here now? We ended up with fetch and decode at D925, which is obviously wrong. So we fetch to ABL from D23, which is 89, so that's good. Then we do the read and increment, and it should make the address bus 8A, which it is, so that's good. And then fetch indirect, I need to print what fetch indirect is actually reading. Oh, fetch indirect is probably using fetch, and probably shouldn't be, actually. Right, because this is fetch byte, which is not what we want. We want get byte, and we want to do it with self.get ab. Okay, and then that ought to do it. New World Wine. Oh, yeah, it's CPU. Washington has some good wine, man. I don't know what to tell you. It's a meme, you dip. I had no idea that was a meme. That seems like a dumb meme. Attempt to add with overflow. All right, cool. We'll fix that in a minute. But let's see, 22, 22. All right, and then, yeah, all right. So now when we look at this one, we get A is 89, X is 65, Y is 0, P is A5, again, that's wrong, and S is, okay, cool. Getting defensive when somebody tries to call him out. Typical spy. True. All right, what's happening now? Instruction B1 at D940, which is a load A with an index, which is apparently trying to add with overflow. Okay? That's not terribly surprising. I called out specifically something that was going to add with overflow. So that's 168, which is right here. Yep. I literally said, oh yeah, and then this could overflow. All right, let temp high-add equal cpu.avh plus, or as u16 plus 1 u16. Oops, that's supposed to be a semicolon. If temp high-add is greater than 0xff u16, then what is supposed to happen? If you have ff here and then you add 1 to it, I mean, I guess you just, all you have to do actually is clip this, right? Because if it does roll over, no, you do have to add it to the low address register, which could then be ff and could then overflow again. It does not wrap around, at least not on the 8-bit level. Okay, so let's say that my address bus was FFFF, right? And then I add Y, which is 1. I get 100 in L, which means that the high is off by 1. So then I add the 1 to the high, and then it just falls off the end, and I end up with 0, which is totally fine. So I literally just have to clip this. That's fine. AVH equals temp high-add and 0xff. Or actually, it doesn't even need that. It needs as u8. Nice snake emote. Or squid, I guess, emote. Snickers. Okay, Invalid instruction 11. Which should be this aura. Hey, would you look at that? I made progress. Alright, it's 7 o'clock. Di, did we ever find out whether we're playing at 7 or 7:30? Can you inform the rest of them that it will be 7:30? It's 11. And we're just going to take this here. Boop. And then aura. And then instead of read to, we're just going to do aura, which doesn't take an argument because it just works. Expected microphone. It is a microphone. Is it supposed to take an argument? I thought I didn't have it doing that. I guess I do. Okay. Or fetch byte from. Oh, okay. It needs like a source, which is going to be reg names ABL. All of this just works. Todd. Who is Todd? Alright, cool. Instruction 31. Yeah, once I figure out the addressing modes, it's pretty straightforward, I guess, to extend the instructions to cover them. And Todd Howard? I don't know who that is. Or why I should know who that is. 30. It just works. Everything breaks from Bethesda, the director behind the Fallout games. All I know about that is that they're getting yelled at currently because they released some sort of tone-deaf subscription thing on approximately the same day that the people who actually made the original Fallout released their like new hotness game. Is that right? Sounds about right, lol. Okay. Imagine doing integer arithmetic with floats. You can do that up to 58 bits. Or, no, that's doubles. 23 bits? Something like that. 71's gonna be add, yep. How bad is using all these vex for your cache locality? Which vex? The answer is probably not great. Like, this is not a super cache optimized design, but I believe that the basic technique is adaptable to being like cache friendly. I just haven't spent any time on that at all yet. If you really want to see cache unfriendliness, look at that URL thing that you talked about, or that you mentioned the other day, because that I implemented directly from the paper, and it is all linked lists. Anywhere you could have a linked list. It's like, oh, this is a set, but we represented it as a linked list. Like, why? Why are you doing this to me? And the answer is because it's 1970. No, I mean, results should be fine because it's a constant. The only reason it's a vector is because I am still adding stuff, and it could easily be constant later. Well, maybe not, actually, because it's ragged. I could turn it into a constant if I wanted to. I bet paper writers love linked lists. I mean, I guess if I was writing a paper, I wouldn't give a shit about whether it was a linked list or not. Oops. Because all that matters is like the theoretical bounds, which he proved are very good. Or, you know, relative to other stuff for a particular class of problems. Now, what is wrong with linked lists? Linked lists are extremely not cache friendly, right? So they were great back in the day, or well, they were okay back in the day. But nowadays, you're chasing all over your memory, and your processor cache is basically rendered useless, which is like using your cache effectively is basically the key to getting good performance on modern processors. That and avoiding branches, but even that's not as good or even that's not as important, rather, because branch predictors turns out very good at their jobs. Linked lists are super popular though because you get taught them in CS class. It's like how everyone in their first several years of being an EE reaches for an op-amp for every single problem because that's what they were taught, even though a lot of problems don't actually require op-amps. An array list is a far better default and might be easier to understand. Yeah, that's debatable, the easier to understand part, but it's definitely better for cache locality, that's for sure. Am I looking at the wrong thing again? Yep, it's 91. Which is store accumulator. Okay, that'll be fun. $91. STA indirect. So the only difference really is going to be that the store, you use store instead of or, right? A vector is easier to understand than a linked list. If not a vec, then it's a deep, vec-deep, or some other data structure, very likely not a list. I have some amount of love for lists because I did learn Scheme first in school, and I think it is a good teaching language. Like, you can learn a lot of things that are good, like, pedagogically from learning about lists, but does the cache depend on memory or access to be sequential? Yes. If you have a 10,000 megabyte vector and you only access every 10,000th element, the cache is likely to figure out that you're doing that sort of strided access, and it will like prefetch the next thing into the cache bucket. Maybe not for 10,000. 10,000 is pretty big, but for smaller strides, it usually can figure out what you're doing. Okay, indirect jump. Let's learn about indirect jump for a moment, shall we? What time is it? 7:05. Imagine not being done with the CPU yet, shaking my head. Yeah, where's your NES emulator, Pixel? Absolute indirect addressing jump. Oh boy, okay. Again, not saying that linked lists are totally useless. They're just sort of fraught. You have to be careful if you care about performance, that is, which not everyone does, and that's fine. Okay, so step 1, fetch opcode. Yeah. Step 2, fetch pointer address low, increment PC. Step 3, fetch pointer address high, increment PC. So the idea here basically is that we fetch the address from the PC, and then we fetch the next address from that address. Okay, so we can do that. Okay, so we're gonna fetch to address bus low, and then we're gonna fetch to address bus high, and then we're going to read to reg names IDL, and then we're going to do, we have a fetch indirect. We kind of need like a read and copy, I guess, which is what I have here. Read and copy, and this needs to be a read and increment, which I forget what that does, even though I was just there. Takes right, so we're going to write to the IDL, and we're going to fetch from the address bus, which makes sense. And then all we need now is love and beer. Fetch and copy, which I think just turfs out to fetch and copy, which is like a super weird thing for me to have done. We're going to do read and copy, and it's going to be CPU underscore underscore. Okay, so what we want to do is, first of all, fetch. So CPU regs pch equals CPU.get byte CPU.get ab. And then we want to update regs PCL to IDL. And that should be it, right? PCH will always be fetched from the same page as PCL. Page boundary and crossing is not handled. Okay. That's not going to be right. Because the address bus, when you read an increment, that specifically is going to increment in such a way that it is going to bump PCH. Yeah, or ABH rather. That's not going to work quite correctly. Well, let's just see what happens. I mean, it's not going to be right, but... Invalid instruction 0. Cool. What dumb thing did I do? Oh, I didn't change this name. That's what dumb thing I did. And then I didn't probably define that either. Right? Yep, I have jump abs, but not jump ind. So many warnings. Ah, shut up. I'll fix it. 6C. A lot of it is like stuff's not used, but it is used, it's just not used in this test program. So it'll all just sort of naturally go away. Invalid instruction C7. Not a real instruction. What dumb thing did I do? So it goes from DBB5 to 300, which obviously it does not. Wait, was I not even at DBB5? I somehow seem like I've broken this even more. Alright, let's just comment this out for a second and make sure that we were actually where I thought I was. Config adder test allow dead code. Yeah, okay. When you're right, you're right. I can't argue with you. Invalid instruction 60 at DB7B. Okay. So I was just looking at the wrong thing. Okay, so let's bring this back. Run you again. DB7B is what we're looking at. 7B. And then we go to 7E. Except, yeah, we do fetch. Oh, at A9 7E, which is super not correct. Cool. Cool. Wonder what happened here. This is a good last problem for the night, and then I'll head out, because I do have other things I need to do, unfortunately. Or, well, fortunately, it'll be fun. Okay, let's debug, shall we? What did I call it? Read and copy. Address. CPU get address bus. IDL. CPU.idl. Okay, let's see what this has to say. Address 201, IDL 7E. Is that right? Yep, 201. IDL 7E, yep, that's correct. CPU.get byte, CPU.get ab, line fetch, PCH from address, val, get ab. It is looking like maybe I stored the wrong thing to that address, which is not ideal, but alright, what am I looking at here? Fetched, oh no, we fetched PCHDB. So how come it's at A9 now? A is DB? Oh, well, A was already DB. What incredibly stupid thing did I do here? PC is now CPU.getPC. Am I like convincing myself that it's broken when it isn't broken? It says PC is now DB7E. Oh, and then it runs fetch and copy? Why does it do both? I probably just forgot to delete this. Yup. Dumb. Okay. Better. Well, not a lot better. So that was DB7B, and it looks like that worked correctly. But then we get to DBB5, which is right here, and this is the one with the wraparound where it has to do that correctly, and it's wrong. My hair is progressively getting messier. Okay, you're right. Sorry. I had angst. Okay, so this is, I already know what the problem is here. The problem is that they're doing a wraparound when they shouldn't be doing a proper wraparound. Read and increment. Instead of doing fetch byte from, we're going to do get byte. as U16. No, that's not right either. Damn it. Fetch byte from. Let's fucking inline it. Because we know what we're going to be fetching from and to. I mean, the to can stay configurable. That's fine, but we'll leave the address alone because we know. Right, so read inc no wrap is only going to have a to reg, not a from reg. CPU.get address bus. And then what we're going to do is CPU get byte, CPU.get AB. Set the to reg num. And we're going to do let temp ABL equal ABL as U16 plus 1 U16. And then we're going to do CPU.ABL equals temp ABL as U8. Oh, CPU dot. Okay, and then if we change this to do read inc no wrap and delete this. And again, this probably doesn't deserve its own microoperation. There's almost certainly a cleaner abstraction for a lot of this stuff, but getting register number 0, yeah, of course, because I forgot to add it to the thing down here. Speaking of bad abstractions. Inc no wrap. Go. All right, invalid instruction B9 at DF60. Is that correct? DF60, B9, load A, indirect Y. Wait, don't I have a load A, indirect Y? Nope, apparently not. Oh, no, I do. B9. Oh, absolute Y. That's why. Okay. Well, yeah, this is a good time to stop for the evening. I have to get ready for D&D. That was what, like, I don't know, hour and a half? It's pretty good. Hour and 20 minutes. Thanks, everyone, for coming by. I really appreciate it. It's good to see you, Silver. It's good to see everybody from the Discord. Postal Rat, thanks for joining us. It's always good to see a new face, especially someone who's not from the Emulator Discord. I will be back probably not tomorrow. Maybe for a little while tomorrow, but probably not tomorrow. I'll do 8 hours this weekend in probably 2 4-hour chunks, although maybe a little weighted towards Saturday. Feel free to stop by. I really enjoy having people here to talk to while I'm just kind of working through this. Ideally, we will actually get to some graphics stuff this weekend. Although I think I have at least another couple hours of CPU operations to get done. So long, Sai. Thanks, everybody. See you Saturday.